In this video, we will continue on using space switching to finish the animation of our character. I will slightly speed up the video since it's going to be very repetitive based on what we have done just before. We will start with the antenna. They can only rotate on one axis and they can't move. So we will directly use a tracking constraint. First we need to align our empty, so we add a copy transform. We source one of the antenna, apply the visual transform, get rid of the constraint and then offset the empty on the y-axis. Then add to it a child of constraint, source the rig and source one of the antenna, click the set inverse and bake the animation. From there, select the first antenna, add a locked track constraint, source the empty. The track axis is positive y and we want to rotate around the x-axis. From there we can get rid of all the undesired channels, make the z-location curve cycling and offset it by a couple of frames. Then you can play on the influence of the constraint if you want to reduce the amplitude of the motion. Remember that offsetting the curve will change the timing, and changing the influence of the constraint will change the spacing or the amplitude of the motion. From there we can bake the action onto the bone, get rid of the useless transform channels, and since both antennas were originally aligned, we can directly constrain the big antenna with the empty. Just go back into pose mode onto the armature, select the antenna, go into the bone constraint, add a locked track constraint, source the empty, track with Y, rotate along X, and check the animation. Since this antenna is slightly bigger, it will have a bit more motion, and I've also decided to offset the empty curve by one additional frame. This way, the big antenna will be slightly delayed compared to the motion of the small antenna, and we will have a more interesting motion. Then I've baked the action and cleaned my curve. Now that the antennas are done, I will unhide all the controllers, select my visibility property bone and display the arms, and we will work on both arms. The idea is to input a slight rotation delay on the shoulders of the robot. To do so, we will again use aim space and a locked track constraint. I will first align my empty by adding to it a copy transform constraint. To work a little faster, I've just copied the name of the arm controller. This way, when I'm adding the copy transform constraint to the empty, I can source the rig and then just paste the name in the bone field. As the empty is now aligned with the arm controller, I will apply the visual transform, then get rid of its constraint and offset it on the x-axis on the side. Then, as usual, I will add a child of constraint, source the armature, then the arm.r, click the set inverse to reset the position and bake the action. I will get rid of the useless curve, and then for the remaining one, I will make them cycle, pressing Shift E, click Make Cyclic. Then we will get back to our controller, go to the bone constraint, and we need to add a locked track constraint, pointing toward the negative x-axis and rotating around the y-axis. So in the constraint, I will source the empty, choose the track axis minus x, and choose the locked axis y-axis. Now I believe that you do know the process. Whenever I move the empty, the arm will follow. So I can offset the animation curve of the empty and then bake back the motion. Don't hesitate to play a bit with the animation curve of the empty. If you scale it on the y-axis using the bounding box, you will increase the amplitude of the motion. Don't hesitate to experiment again. If you fail, you just need to rebake the motion. So as I'm happy with the result, I will bake the action onto the arm right controller, get rid of the transform channels that are useless, and I will repeat the process on the left arm and also the connection between the rocket launcher and the left arm. So I will let you there with a little time lapse and we'll go ahead at 7:54. Now we can work on the minigun. It has already a tracking mechanism, so we can go ahead with a simple copy location of the MT, source the minigun target and bake the motion. As the action is baked on the MT, I will select the minigun controller, add a copy location constraint and source the MT. As we did for the head, I'd like to remove a bit of the bounce we have on the Z location axis for the minigun, because it looked like it's not very controlled by the robot. So having a bit of follow-through motion is okay, but too much make it looks like it's very clunky and not a very reliable weapon. So what I'm doing, I'm first smoothing the Z location curve of the MT, getting rid of the bumps. And since we have two up and down motion over the 72 frame, I can work on half of this curve and then remove the second half. The cyclic modifier will take care of repeating the curve seamlessly. So what you need to understand is the time you will save using this method for this kind of motion. We will use space switching later in the course to smooth some animation, but for this kind of robotic motion, that's so handy. I will repeat the process on the X location curve to kind of remove a bit of the noise we have in the motion. So this time I will have to work on the whole curve because the left to right motion uses the 72 frame of the whole cycle to be performed. The idea is just to get rid of the few glitches we have on the curve. What is so powerful about aim space and this technique is that even if the root of the minigun, the point where it is attached, is very shaky because we had a lot of noise and secondary motion, if we have a smooth motion of the target, then the tip of the gun will have a very smooth motion. And so you can create very complex animation with ease, while that will be almost impossible to counter-animate in a classic fashion. For the rocket launcher cap motion, I will simply use a locked track constraint. It's gonna be the usual process, so I will repeat it for you. First, we need to add a copy transform to the empty, apply the visual transform, get rid of the constraint, offset it in this case on the y-axis, add a child of constraint. As a target, choose the armature and the cap controller, set inverse, and then bake the action. Get rid of the useless curve. Again, you don't need to do it. I prefer to do it for demonstration purpose. Then onto the controller, add a locked track constraint. From there, get back onto the empty, make the Z-curve cycling, offset it in time, and see what happened. The only little difference here is that our controller has already a constraint that belongs to the rig. So this time, when I will bake the action, I will uncheck the clear constraint box. It will bake the action as usual, but now I can manually get rid of the locked track constraint without losing the original constraint that has been put there by your lovely rigger. The last step is to work on our artillery piece. So using the visibility bone, I will enable the visibility of the artillery. It can move up and down and rotate a bit. So what we will do is that we will first use our copy location constraint to create the up and down follow through motion, and then a tracking constraint to get the rotation. With my empty selected, I've added a copy location constraint. I've sourced the armature, then sourced the artillery pivot controller and baked the action. We can then reverse the constraint, meaning that I will select the controller, add a copy location constraint and source the empty. Now I feel like I've repeated this enough, but I will go ahead either way. I will slightly offset the Z location curve just after I've made it cycling. I like the result, so I will bake this action onto the controller. So I need to select my armature, select the controller, click bake action, and this time I can get rid of the constraint by checking the clear constraint option. Let's now work in aim space, so I will select back the empty, add to it a copy transform constraint to align it with the controller of the artillery piece. Then, as usual, I will apply the visual transform, get rid of the constraint, and offset it on the y-axis. Then we need to add a child of constraint, source the armature, source the artillery pivot controller, click the set inverse to reset the position, and bake the action. Then I need to use a locked track constraint onto the artillery since it can only rotate around its x-axis, and the forward axis will be -y and the rotation axis will be x. From there, I will repeat the process I did on the minigun. I want to show that this piece of artillery is very heavy, so I don't want too much glitches and too much bounces onto its animation. Since we are using the up and down motion, we can work on half of the curve. And then what I will do is that I will remove as much keys as needed to smooth the curve and get a very smooth motion of the tip of the artillery cannon. Again and again, don't hesitate to remove keys. Don't hesitate to fail because you can just rebake the action and start over again. That's very fast. It's a very iterative process until you get to the result you want. And that's a very easy process, so in a way that's very creative. What is super interesting about this piece is again the root or the base of the artillery is shaking a lot while the tip of the artillery will be moving in a smoother fashion. This brings a lot of texture to your animation. And while it can be very subtle, all those little variations in the motion of your character will make this robot believable. And while it's a piece of machinery, it's also a way to put life into this character. What makes it alive is that this robot is communicating something. Weight, strength, power. That's some kind of dreadful character we have here. So as we are almost done with this animation, take the time to watch it entirely. I feel like the head motion is a bit too strong. So what I can do now is simply take the head controller and reduce the amplitude of the curve I want. In this case, I feel like the up and down motion is a bit too strong, so I will head up to the Z location curve, and I can see that my 2D cursor is currently aligned with the value 0, which means no motion. So I can switch to the 2D cursor pivot and scale the curve down on the y-axis, and it will reduce the amplitude of the up and down motion of the head. And since we've baked all the motion of all the other parts in their local space, and they are kind of attached one to the other, whenever we modify one piece in this way, the other follow. So if I want, I can select the cap of the rocket launcher and increase the amplitude of the rotation and get more motion. I can also offset the whole curve on the y-axis and change the whole orientation of the cap. And here we are, in a very short time, we were able to animate this full character with a lot of variety, texture and interesting motions.